Hi, everybody. My name is Rishabh Lala, and I'm here with a team of five really excited individuals to present on the topic of FiOS network reliability system. So I have Rohini Kasat, Nitish Shetty, Chitra Chetty, and Varsha Disawal to present on this topic today. So FiOS or fiber optic service is a network reliability assurance system of a Fortune 500 company. The purpose of this system is to ensure network speed and network reliability. If the network speed falls below a certain threshold value called key performance indicator, or if the customer calls and makes a complaint that my service is really not working, so there's something to look into. There are tickets to be raised. There is dispatch technician to go out there and fix the issue, and there is some system built alerts that really get triggered when the network falls below these key performance indicators. So let's dive into how this whole system really working and how each activity gets triggered and at what time. And really, this is a chance for us to dive into of a system of a Fortune 500 company. So stay tuned and stay excited. Here it comes.
Hello, I'm going to briefly go over the information system which we are designing for this use case. It's called a service assurance and dispatch system. This is a fiber optic service for residential customers, and the services provided are voice and data and video services, which are provided by a Fortune 500 company. The features which the customer support and network operations personnel should get out of this system, or they should be able to authenticate the customer whenever a customer calls with a trouble or repair issues with his service, and also provide means to troubleshoot the issue, resolve the issue. If they cannot resolve the issue, the system should provide features to dispatch a technician and then get that resolved, and also capture the resolution, customer feedback, and additional upsell features when a dispatch technician goes to the customer's location. So that's a very high level summary of this system which we are designing. As part of the activities covered, we went over the requirement. We had multiple requirement gathering sessions with the subject matter expert. In this case, it is myself, since I have extensive experience of working in this technology and environment. Team also went over the network architecture and understood the entire network ecosystem. And we defined the scope. We went through the questions and answers. Questions were asked by the team to me, and I provided the answers which are captured in the requirement analysis document. We also worked together in building use case diagrams, activity diagrams, class diagrams, sequence flow diagrams. And then we went over the requirement and built a requirement analysis document along with the gap analysis, and the scope for improvements were also covered. The main things we covered in this are the functional and non-functional requirements. What are those functional requirements? Functional requirements are gathering the customer service details, and when the customer calls, authenticate the customer and understand his issue and provide a way to present the issues and troubles to the customer service personnel, and features to create tickets so that you can audit that customer call, and additional features to investigate the customer issue by viewing the alerts and trying to troubleshoot proactively or reactively. If the customer support personnel cannot resolve the issue either by troubleshooting proactively or reactively, then this system should provide features to dispatch a technician, and this dispatch system should cover the appointment time and assigning the dispatch to the right technician. And also once the dispatch technician goes there and resolves the issue, it should capture the resolution details, capture the customer feedback. On top of all this, when the customer issue is resolved and the dispatch personnel is at the customer's location, the system should prompt the dispatch technician based on the customer services an upsell feature so that additional services and features can be sold to the customer or at least prompted so that if the customer prefers to buy them, this system should have features to accept that and customers should approve that. So those are the functional requirements. What are the non-functional requirements we cover? Non-functional requirements are how this system should be compatible with various operating systems like Windows, Mac, or cloud environments like AWS. It should be compatible with AWS environments. And also it should have various security features and follow AWS best practices in terms of security. It should also have authentication and access mechanisms where a customer representative or network operations center personnel can log into the system. We authenticate him and also provide right access features using role-based access features. And this system should be highly available and also reliable by having geo-redundancy features so that if there is any outage in a primary location, the secondary environment should pick up and seamlessly provide user experience to the end users of this system. There are additional business requirements we covered, that is to provide continuous service to the customer and make sure that the service provider constantly monitors the customer service through the system. End users requirements were also discussed, that is how we can seamlessly provide a service which is as promised, and also if there is an issue, how we can resolve the issue using the features provided by this system. And then there are additional system requirements were covered, which are performance related in terms of how this system should perform in an environment by leveraging or using right memory usage, CPU usage, etc. So those are the non-functional requirements we covered. With that, I will hand it over to the next speaker.
So this is the use case diagram of the system that we are analyzing, Verizon's network service maintenance system. As you can see, the diagram calls out the high-level functionalities and defines the scope of the system. So to the left of this diagram, we see the primary actors who are the customer, dispatch technician, and customer support. And the main use cases are called out within the system. And then we have the subsystems called out to the right, which are the service assurance and dispatch system, and the customer feedback and reporting system. So these are the subsystems with which our use cases would interact. So coming to our primary actor, who's the customer. So whenever the customer faces a network issue, he or she would raise the issue, which is tracked in the service assurance and dispatch system. He tries to get the issue resolved either with the help of the customer support technician or the dispatch technician. And once the issue is resolved, the customer would leave a feedback for the services provided, and this feedback is tracked in the customer feedback and reporting system. Initially, whenever the customer faces a network issue, he would get in touch with the customer support who tries to resolve the issue remotely. In case the issue is not fixed, then the dispatch ticket would be raised and the dispatch technician would try to resolve the issue that was raised by the customer by visiting the customer's place. During this process, if there is involvement of any upsell, then the customer would agree to the upsell, and once the issue is fixed, he or she would provide the feedback, and this feedback will again be stored in the feedback and reporting system. So this is the overall functionality of the system at a very high level, and detailed functionality or flow of the activities could be covered in the following behavioral diagrams like activity, class diagram, or the sequence diagram.
Let us now talk about the activity diagram. An activity diagram is a type of behavioral diagram that depicts the flow of activities within a system or process. It illustrates the workflow, control flow, and the organization of the activities for the fiber optic service system. The whole system is divided into three activities: issue ticket, raise ticket, and customer feedback. All these three activities begin with an initial node and end with a final node. Let us look at the first activity on the left. When a customer faces a trouble or an issue, then either the customer will call or customer will not call. If the customer calls, then the customer support representative will collect the information. If the customer did not call and the issue still persists, then the alert will be generated by the system and the information will be provided to the customer care representative and the issue ticket will be raised. Either way, customer calls or the system picks the error, an issue ticket will be raised by the system and the activity ends there. Let us look at the second activity, which is more involved. If the issue was first reported by the customer call, then there are two activities or steps that are triggered. First is investigate the issue. Second is initiate self-troubleshooting steps. Issue will be either fixed by now and the loop will close at the merge node at the bottom. If the issue is not fixed, then reactive troubleshooting steps are triggered. A dispatch ticket will be raised if the issue did not get fixed with the reactive troubleshooting steps. If it gets fixed, the activity ends there with X, or the end activity node. To fix the issue, the dispatch technician will either need to do an upsell or he would not need to do an upsell. He identifies the root cause. Based on that, he decides to do an upsell or not. But if there is an upsell required, a payment agreement form is signed by the customer, in addition to the selling of the equipments that are required. This way, the issue gets fixed and the activity ends with merge node and the final node. Now let us talk about the third and the final activity. So it's the customer feedback. Customer either denies to give the feedback or he agrees to give the feedback. Either way, the activity closes and final node is reached. Now let us talk about another type of behavioral diagram in the unified modeling language called the sequence diagram. This represents the chronological flow of the messages that gets exchanged between different actors. Here, the key actors are a customer support, service assurance and dispatch system, a dispatch technician, and customer feedback system. These diagrams represents the sequence and exchange of the messages beginning from the top left. Customer calls the customer support and provides information including but not limited to the account number and the issue. On the same level, we have service assurance and dispatch system, which also provides issue information to the customer support representative. Now, based on that information, customer support representative issues a ticket. The next step is to investigate the issue by self, and it's self-performed by the customer support. Based on the investigation, the first step triggered by the customer support personnel is to self-troubleshoot the issue. The customer will have to perform few steps and he self-troubleshoots the issue. Well, this might fix the issue, but if it does not, customer informs the customer support, as you can see in this arrow. The customer support triggers reactive troubleshooting steps on the service assurance dispatch system. The third row is the service assurance dispatch system. If the issue gets fixed, then the customer support informs the customer about the issue is fixed. However, if the issue is still persisting, customer support generates a dispatch ticket on the service assurance system. The dispatch technician then gets out to identify the root cause of the issue. Now, it may or may not be required to do an upsell by the dispatch technician. If it is required, the technician will inform the customer about it, and the customer will have to provide a dispatch agreement form to the dispatch technician. He accepts the upsell in that form, and finally, the issue is fixed by the dispatch technician, and the customer is informed that your issue is fixed. And finally, there is an optional feedback that the customer provides to the dispatch technician. This way, our sequence diagram is completed. And let's talk about other diagrams now.
So this is our class diagram. Let's first have a look at customer support personnel class. So this CSP supports the customer, and a CSP might not support any customer and can support many customers, and a customer might be supported by 0 or many CSPs. So whenever there is an issue ticket is created, and this issue ticket is always assigned to a customer support personnel. Whenever the system generates an error due to any service issue, this alert in turn creates an issue ticket. So an alert will always have a issue ticket, but an issue ticket might not be generated by an alert, because there may be a case where a CSP would create a ticket manually after receiving customer's complaint. After issue ticket is created, there is issue investigation. So this issue investigation class has two child classes. One is system detected error investigation, which is a result of this alert which was created by the system, and the other is customer issue investigation, which a customer support personnel conducts once he receives or she receives the complaint from a customer. After this issue investigation, there is troubleshooting. It results in troubleshooting. Whenever there is an investigation, there would always be a troubleshooting, and a troubleshooting would always be followed, would always follow an investigation here. After troubleshooting, there may be a case where the issue is still not fixed, then a dispatch ticket is created. So that's why it will always be 0 or more. That troubleshooting will create 0 or more tickets, because there may be a case when it would not be required. After the dispatch ticket, the dispatch ticket is assigned to a technician. It has a technician. And this technician then goes ahead and finds the root cause. So a technician will always find a root cause and can find many root causes, whereas a root cause would always be found by one or more technicians. After this root cause is found, it triggers an upsell, but it's not always the situation. So an upsell may be triggered even though there is no root cause for it, and it's generally taken by the customer, even though it's not related to the current service issue. And there can be a case where a root cause would not require any upsell. So it's always 0 or more upsell that are triggered by the root cause. So this in all is our class diagram, and these are all the relations in it.
Part of the final conclusion, we think we have covered all the corner cases and all the aspects of this information system, which is service assurance and dispatch ticket system, based on the class diagrams, activity diagrams, sequence flow diagrams, which was followed as per the examples provided and the lessons learned in the classroom. The application has all the essential features for the service assurance person and also the dispatch ticket person. On top of that, we also provided the upsell features, which is an added feature in this system. Now, coming to the conclusion, what could have been improved or what other features we can add to this system? We think by adding artificial intelligence and machine learning capabilities for this system will further enhance the system, and it will reduce the dispatch tickets and the customer calls coming into the service provider, which will reduce tremendous amount of expenses to the company with proper collection of data and also making the machine learn the scenarios and issues and then modeling them as per the requirements. This will help further proactively troubleshoot the issues and reduce customer calls and also dispatch tickets. That's one of the improvements which we think can be implemented on this system. And on top of that, if we can provide better tools and troubleshooting features even to the dispatch technician, it will help us. Certain times when the dispatch technician who goes to the field, if he has no knowledge of certain problems, it will help him if we provide certain mops and tools within the dispatch system, which will help him to troubleshoot the issue and also fix the issue when he's at the premises. Otherwise, we will have to do another dispatch, which will be adding to the cost of other expenses of maintaining the service. So those are the two improvements which we think we can implement here. With that, I'm concluding this section. Thank you.